And then when we look at the nucleus, again reminding you that we are breaking down the cell into the cell membrane, cytoplasm, and the nucleus being separate, the three separate main components of the cell. When we break down the nucleus, we're really looking at what the nucleus does and knowing that it's kind of a control center for the cell. And we should all know that this is where our DNA, or what we're referring to as, oops, that's an M, chromatin, right, that's where that genetic material is going to be located. And we should know again that the nucleus is kind of enclosed with another bilayer membrane, the nuclear membrane or the nuclear envelope, and that nuclear envelope contains pores, and that those pores are going to be how materials move between the cytoplasm and the interior of the nucleus. So, like I said, the nuclear envelope or the nuclear membrane, that's separating cytoplasm from the nucleoplasm. Sorry guys, that kind of didn't pan out very well. From the nucleoplasm, that contains pores, these little openings to let molecules move in and out of the nucleus. But we know that we don't want DNA to be able to leave, right? But we do want to think about RNA being able to get out. We want to think about the idea that ribosomes need to be able to leave, and obviously we need to have like nutrients moving in to allow for energy to be used. So RNA is going out, ribosomes going out, nutrients in, right, and so on. The nucleolus then is going to be that very dense area within the nucleus, and that area is going to be made of RNA and proteins really densely packed together, really tightly packed together, and this is where ribosomes are going to be made. So obviously when the nucleolus makes a ribosome, that ribosome needs to be able to leave through a nuclear envelope pore in order to get out into the cytoplasm or out to the rough endoplasmic reticulum where it belongs. In addition, like we said, this is where that chromatin or that DNA is going to be located, and when we're talking about it, all right, we're talking about that DNA being wrapped up with those histones, right, those proteins, right, that the DNA winds around. So showing us here that the DNA coils around these little histones, these little protein molecules, and that coiling feature is really what gives DNA part of its structural support as it coils up into chromosomes eventually. And this is where the information for producing proteins, all right, what we're talking about is that process of transcription and translation in protein synthesis. Right, the initial information is from DNA, and it moves from DNA to being transcribed into RNA, and then from RNA it's translated into an amino acid sequence. So that chromatin is where we start off with that genetic information, and eventually, like I said, chromatin coils into chromosomes when we're going through cellular division. Guys, this pretty much wraps it up for our overview on cells. We're going to talk a bit more in depth about cellular transport and about cellular division, as well as cellular disease in future lessons. If you have any questions, please feel free to see me.